Thank you. So the title of the talk is Kick-Ass Code Editing and End-to-End JavaScript Debugging. My name is Fabian Jakobs. If you want, you can follow me on Twitter. And let's get started. So we say code editing and debugging. Why do we do this? We are building an IDE. We're building an IDE for the web. And we called the baby Cloud9 IDE. And what I'm going to do now is, today is present the vision of Cloud9 IDE, but even more describe some of the technical details in building this, because this is a tech conference, this is not a product conference. You can follow Cloud IDE on Cloud9 IDE. All right, so the overview for this talk will be the code editor we use for the IDE, the technical details of the code editor, how plugins work, and a showcase of how we can debug code in the cloud. So to get started, let me give you a small demo how this looks like. Okay, so this is the IDE, just looks very familiar. And one of the basic things you should be able to do with an IDE is create files. So let's create a hello world.js. And the other thing is, you should be able to edit files. Okay, it's all nice, but just having files on the server doesn't help you, so let's run this beast. And you see, well, it's printing something in the console. But where does it actually run? So this could be run in the browser, but it's actually run on the server in a Node instance. And I can prove it to you by changing this to the Hello World version of Node. Does anyone know what the Hello World version of Node is? Right, HTTP server. Let's require HTTP, create server, and this one takes a callback with a request and a response object. All right. And then rewrite success. So we can do this. And close the response. Of course, we have to listen. Excuse me? Oh. Res n, yes. And so we see what's doing. We say HTTP localhost. All right, save the beast, and run it. I don't see something. Oh, okay, let's kill it. Oh, I guess I've just... Okay, let's start over. Oh. 5,000. Hooray! Here we go. Wow. Boom, we run it on the server. So it actually runs a Node instance on the server. We can edit it from here, we can start it from here, and we can stop it from here. So that's the basic overview how the IDE is going to work. Of course, as you've seen, this is still a tech preview. This is far from being a complete product, but nonetheless, we just want to get out early and show what we think could be the next step in writing code in the cloud. So, yeah. So nobody really will use an IDE if the editor sucks. So everyone has his editor, be it VI, Emacs, TextMate, maybe Eclipse or NetBeans. And one of the key parts of the IDE is an editor that actually works. My aim for the editor was that it should at least replace TextMate for me. So all the features I love from TextMate should eventually be available in the code editor. The same for some of the Eclipse features that I really like. So what are the requirements for code editor? Well, first of all, it should be cross-browser. It should not be a big restriction on which browser it runs. So including IE7, IE8. It should be fully featured. It should have all the features we need. It should be configurable. Like users want to show the hidden characters like spaces and tabs, or don't want to see them, and all kinds of stuff that should be able to be configured by the user. It should be scalable. It shouldn't break down on really large files. Like if there are files that are like 10,000 lines long, and should just be able to handle it. And it should be hackable. That means if someone wants to add a functionality that's not there, any seasoned JavaScript hacker should be able to just implement it. So why not Bespin? It's obvious almost all of this is already implemented by Bespin. Sorry, Skype I'll stick to Bespin. And I really think Bespin has done a really excellent job to pioneering in this area, to show that it's actually possible to do advanced text editing or code editing in the browser. But there are some things that didn't fit for our things. One is that it's inefficient if it's scaled to a really big canvas, because it has to draw all the pixels individually. That's like what Paul Backhaus said for his game engine. It's similar to the code editor. It's not cross-browser because it's using Canvas, obviously. So no IE7, IE8, IE6 if you want to, but I don't really care. And when we started, it had a big dependency on Sprout cards, like 500K external dependency on a library we don't use on ourselves. So today it's jQuery, which is a lot better in terms of code size, but still something we don't need for the IDE. So that's why we didn't use Bespin. So we choose to implement our own code editor. So there are several options you can take in doing this. You can have content editable. You can use a canvas as Bespin does, or you can use pure DOM methods to render everything. Let's take a quick look at it. So content editable, well, it doesn't really give you enough control to do advanced stuff. It has a lot of issues to get right cross-browser, and we really wanted to do like fancy stuff with the selection. We want to support in the future like rectangular selections like TextMate does, and there's no way you can do this with content editable. And content editable was really designed to do rich text editing, which we don't really need. So it's not worth it exploring it for code editing. Then of course there's Canvas. Canvas is nice because you have full control about what you want to display. So you can do anything, but seriously for a code editor, I don't care if I can do fancy stuff. I just need some rectangles and lines and text. So I don't really need all of this. And it also means that you cannot run it on all current IE versions, except the IE9 beta, but that's not out yet. And another point is, if you use Canvas, you have to implement all the key and mouse interaction yourself, because there's nothing you can leverage. But that's not actually a bad thing, because it means you have full control over everything what happens. And my very unscientific big O notation is the canvas scales roughly with the number of visible pixels. That means if you have a small canvas, it's all good and fine. If the canvas is really big, yeah, well, it's going to be slow. And then there's pure DOM. So what does pure DOM give us? It gives us drawing text, drawing lines, drawing rectangles, all with different colors, borders. That's all we need. So it should be able to be done. But also, like with the canvas, since we are not using a predefined editor form, we have to do all the event stuff ourselves. So we have to define exactly what happens if you do shift cursor down, or shift page up, and control left, control right. All this has to be implemented manually. The same is for mouse interaction. And the naive implementation scales roughly with the number of lines in the document. So the naive implementation would be put everything in one big HTML document, which means if you have a very large document, the speed degrades. But there's a better way to do this, which scales with the number of visible lines, which is much, much nicer. So, and this is by using a virtual viewport. So the idea is really simple. You always only see a small fraction of the document. So there's no reason to generate any HTML markup for the whole document. You can just generate the HTML markup for the viewport, for the thing that you see. So, as I said, rendering a full document in the DOM doesn't scale, so we only render the visible rows. And if we scroll like this, we just always update the contents. So the updating itself, of course, is a little bit expensive because we have to really easy to implement. So our renderer, we have a strategy of we use the DOM for drawing only. So we don't store any state in the DOM, and we never read the DOM. So we just use the DOM as a painting API, like we would do with SVG or with a canvas, right? And by using the DOM, we can use the composition features of the DOM. So like we can have different layers, which are divs which are stacked behind each other, and each of the layers can draw a different element of the document. Like we have a layer for the selection, we have a layer for the cursor, we have a layer for the text, and if you move the cursor, you only have to update the cursor layer, and you don't have to update the text. So it's really efficient to change the selection or to move the cursor, because it doesn't involve any costly operations. And then you just put it all on top of each other, and that's how the editor looks like. Of course, I'd like to show you some of the features of the editor. Oh. Not perfect yet. Okay, so now we have an HTML document. So one of the features of the document, the editor, is that it has syntax highlighting, of course, but it also has nested syntax highlighting. Like we have an HTML file, but then there is a CSS block, and we switch the syntax highlighting mode to CSS. And a little bit further down, we have a script block, and inside of the script block, we switch the highlighting to use JavaScript highlighting. And then we, as I said, I want to have all the features that a normal code editor gives me. Like, let's assume I want to indent this within the script block. So I can select this, hit tab so I can auto-indent it. Okay, that's much nicer. Then let's say, okay, the onResize method, I think, has a bug. So what I usually do is I create a copy of this as a reference and then comment it out. And I can say, okay, let's do something else. Alert 12. As you see, the cursor jumps to the right position, so we have auto-indenting. So usually in a normal text editor or in a normal text field, the cursor will jump to the beginning of the line. And I'm closing it, and I have auto-indentation. And also you see, I don't know if it's visible, that it's highlighting the matching parentheses. Okay. Well, that's not really fixing it, so let's revert it. So it also has full undo stack. And this is, of course, something that you have to implement yourself as well, because this is just DOM nodes, and all the changes are just changes to the DOM by reacting on the events. Also, the cursor is just a small div that's hidden and shown again and again. Oh. And the other thing was, I claimed that it should be able to handle really large files. So this is a file from our project that's, I think it's generated, but it has like 16,000 files. So in scrolling in this file and opening it, writing code in it, There's really no difference to a file which is only 20 or 100 lines long, because all that matters for scaling is how big the viewport is. So if I had a really large screen, then of course scrolling and doing stuff would be slower because I have to re-render stuff. But this hit is even bigger for using Canvas. Canvas degrades for really large screens a lot more than the DOM. And we only are concerned about the vertical height and not about the horizontal width. All right, so this is the editor. Yeah, plugins. To have an IDE to be really successful, you need a way to plug in external functionality. Because there's no way that a small company like Ajax.org could implement all the functionality that any developer would want. So we can concentrate on the core features, and everything else should be plugins. And in this case, we designed it so everything is a plugin. Search is a plugin, file system is a plugin, the new file dialog is a plugin, even the editor is a plugin. So if you don't like the editor, you can replace it with a different one. The language modes are plugins, so the syntax highlighting and indentation, stuff like this, all these are plugins. So, and the plugin is very simple. It's just a JavaScript file for the client code. It's JavaScript for the server-side code, since we're running on Node. And it's some XML to describe the UI. And we at Ajax.org, we have an UI framework called APF, Ajax.org Platform, which we use to build this application. And this XML is an Ajax.org Platform XML that you need to write the UI. So I've prepared a little video. So let's pause this. So to give you some context, what's happening now? What's happening now is that we are going to write a small plugin which takes the current selection in the editor, which should be JSON, and does a pretty printing of the selection. So essentially it does a JSON parse and then JSON stringify with an indentation string. So what you see here, it's just the template. You have the JavaScript file for the client-side code. It's a template, so we replace template with a format JSON. Right? We save the file. And the UI in this case is an empty window. So, and we add to this window a VBox for the controls. For the controls, we want, and if you click the button, it will call. It will actually call the format function in the JavaScript file. That's okay. Now, so now we are going to write the format function. It takes as argument the indentation. It takes the current editor. So it picks the current editor. And to do this, we need a little information. We need some of the editor API. And so we are accessing the range object. Like you see, this is all using require.js to load the files. Okay, so this is the code. Let me stop it for a moment. And here you see the actual like business logic, JSON stringify, JSON parse, with the indentation as third argument. And at the bottom, we get the range, we get the value from the range, stringify it, and then we do document replace, and then we update the selection. Okay, and in the bottom, there's a little bit of lifecycle management, so there are functions which are called when the plugin is enabled, disabled, initialized, and stuff like that. Okay, so So the UI is completed. Yeah, now we are gone. We can go to the plugin manager. And since we added this within the IDE, we can immediately enable the plugin. So we add the plugin, require.js loads the plugin that we've just written, and now the plugin is enabled. And now let's go to a JSON file. Yeah, and there's the menu option, and here we go. So that's how essentially all of the IDE is implemented. All of the IDE core functionality besides the basic workspace is done using plugins like this. Oh. All right. So now let's go to the debugger. How would you do debugging in the cloud? So that is a big question, because if you host something in the cloud and run it on the server, how can you debug the code that's running on the server? And this is really crucial, because if you don't really have a handle to the application, you can't really touch it. So we need a way to expose that. And the way we are doing this is by using the V8 debugger protocol, which Node fortunately supports. So what we do is the IDE server starts a Node process with the --debug argument, and then connects to the debugger port with a small TCP client. And the IDE server then simply proxies the debugger protocol over socket.io, which is a really nice framework to do server push from the server to the client, to proxy the V8 protocol to the client. And essentially the client implements the whole V8 debugger protocol handling. It passes the messages and keeps the state and stuff, and also issues commands to the debugger. So this is how we can debug the Node application. So there's one missing link, that is, what if you want to also debug the client-side application, like the JavaScript in the browser? So there is a way to do this, but it's a little bit tricky to get it running, because that is by using Chrome. Chrome also exposes the same debugger protocol, but first of all, Chrome has to be started with a command line argument. So you have to have a way to start Chrome, and then, well, you need a way to connect to the Chrome browser, which is tricky because the server cannot do it. So the client has to do it, and to do this, the client would have to have a plugin or something. Okay, so we had a prototype showing Chrome debugging, but it's not in the IDE yet. So this is something that's going to come. Okay, let's do a small demo again. So this is really the most exciting demo for me. Okay, so let's go back to our application that we've written before. I happen to have this open. So let's. Is it running? Okay. Shit. All right. Okay, we put it here so we can see it. Can hit reload. All right. But instead of hitting run, we can also hit debug. What this does is it makes the viewport very small, but also it starts the Node process with a debugger argument and connects to it. So what I can do now is I can set a breakpoint here, and if I hit reload, I can it breaks at this breakpoint, I can do stuff like navigating the call stack. Let's see, it's called by event emitter. And this comes from HTTP. And this comes from socket. And this also shows code that you usually don't see on the hard disk because it's compiled into Node. But the debugger protocol also exposes it. And what you can do as well is, let's go back, of course also inspect the local scope. Like you can go to the request, can take a look at the headers, stuff like that. Well, and then of course you can do stuff like step into, make this a little bit smaller. So I'm now stepping into Node. I'm not really interesting. I can step out and then I can say, okay, let's continue. So this is how I can do debugging. But there's also one feature that makes it a little bit more interesting. Let me show it to you. I have to change the code a little. I can click on it and inspect it. But I cannot only inspect stuff, I can also change stuff. Like I can say message is yoo-hoo JSConf. So what this means, I evaluate this code in the current context. That means I'm changing the variable in the closure. And if I continue now, you see yoo-hoo JSConf. Right, pretty amazing, yeah. So, let's continue. And if I reload, of course, now it will always return yoo-hoo JSConf because it's now stored in the closure. So, but this is just the beginning. You've seen it still has a lot of edge cases. It's not a product yet. But I still think it's nice to show what you can actually do in running stuff on the web. At the moment, this runs totally locally. So this is something you can install locally on your machine. And then immediately start working on your code on your machine. Yeah. Will you do an NVM install? We have an NVM package, yes. And yes, you can install it with NVM. NPM. Right, so that was the demo. So we can come to the closing words. So our vision is to eclipse what Google Docs is to Word. That means all the important features, plus all the features, all the benefits of being in the cloud. So we really want, the next step will be to move this onto a hosted service to run it directly from a server. At the moment, it's all local. And we would like to thank the community, since we are using a lot of stuff that you guys have built. We are using Connect as Node web framework. We use Socket.io to communicate from server to client. Of course, we use Node.js, and we use Require.js to do the client-side loading and plugin loading. And I really love to use Require.js. I would even love it more if I could use Require.js modules directly in Node. Maybe that's happening. And then, of course, we are also contributing stuff back. There's a lot of code that we release as open source as well, or maintain as open source. That's for one APF, the UI framework. That's JS dev that my colleague Mike has done. It's a Node-based web dev server, which we use to use the file system stuff for the file system tree. We have Node 03 XML. We're not using it yet. It's a wrapper for libxml and a fast wrapper for Poogie XML, which is a very fast XML library with a slightly limited feature set. We're going to use Node GitHub. That's a library that I've written to access the GitHub API, and we're using async.js. It's a very small library by me which basically wraps the Node file system API. And on top of this, we are releasing the full editor source code today as open source, which also contains the implementation of the debugger, V8 debugger protocol. Well, that's not it. So we also release the full source code of the IDE today. So you can go now to GitHub, check out the source code. It will probably break in a lot of cases, but you can try to take a look at the source code and hack on it. So the servers are up and the projects on GitHub are open now. So I really would like you to join us in building the JavaScript IDE for JavaScript developers by JavaScript developers. That's our vision. And that's it. Thank you. Okay. Are there any questions? Martin? The IDE itself will at the beginning be a GPL. The editor and the Node debugger are LGPL. We are considering in using a more liberal license later, but at the moment we want to stick to GPL for the IDE. Yeah.
Can the editor be embedded in other sites, or is it?
Yes. Yeah. One of the design goals for the editor was to not have a big dependency on anything else. The editor itself has no external dependencies besides require.js. So we don't use any external. We are not doing it right now, but we are really we really want to have this in the future, that you have some collaboration on code editing. That's part of our plan. It's not implemented yet. There was. Yes, we do want this. We don't have it now. At the moment, it's something you can install on your PC and edit your local files with a local file server. But we definitely want to make it a hosted service, and we definitely want to have some collaboration features where you can work on the same source code, maybe with a chat window on the side at the same time, yes. Yeah. I'm pretty sure it's not working on the iPad. So I haven't tested the iPad yet, but since we are depending heavily on the UI interactions to interpret what's happening manually, I'm pretty sure it's not working on the iPad yet. But if you want to make it work on the iPad, I would be really happy. So. All right. Then thank you for listening, and talk to you later.